Here we should discuss the inspection method, which is method 5. So to find an integrating factor mdx plus ndy is equals 0. With some experience, integrating factors can be formed by inspection. For this purpose, the following differentials are given here. So here the differential equations are like d of x comma y is equals to x dy plus y dx, and then d of x by y is equals to y dx minus x dy by y square, and d of y by x is equals to x into dy minus y into dx by x square, and then d of x square plus y square by 2 is equals to x dx plus y dx. D of log of y by x is equals to x dy minus y dx by xy, and then d of log of x by y is equals to y dx minus x dy by xy, and d of tan inverse of x by y is equals to y dx minus x dy by x square plus y square. Then d of tan inverse of y by x is equals to x dy minus y dx by x square plus y square. D of log of xy is equals to y dx plus x dy by xy, and d of log of x square plus y square is equals to 2 of x dy plus y dy divided by x square plus y square. Then d of e power x by y is equals to y into e power x dx minus e power x divided by y square. So when we solve the problems, if it is in the form of for example, if we take d of x comma y is equals to x dy plus y dx, in question if x dy plus y dx is there, then we can use the d of x into y. So here it's very easy. D of x by y, if you remember, then d of y by x will be very easy. So here x of if we get d of x by y, then the formula is y dx minus x dy by y square. Then if we have y by x, then we can interchange the terms here. So x dy minus y dx divided by, here we got y square, so here you will get x square. Similarly, for log and for tan inverse, you can easily remember. So whenever you find the these right hand side terms, then you can use the differentiation in problem. Let's see few problems on this inspection method. So here we have solve x dx plus y dy is equals to x dy minus y dx by x square plus y square. So now this is a given equation. Then we can write it as by using differential. So from that formula, x dx plus y dx can be written as d of x square plus y square by 2, and here x dy minus y dx by x square plus y square can be written as d of tan inverse of y by x. Now we integrate on the both sides. So d nothing but the differentiation. So when we integrate it, integration and the differentiation gets cancelled. Then the leftover terms are these. So we get x square plus y square by 2 is equals to tan inverse of y by x, and we get plus c, that is constant, because since we are integrating it. Then second question, solve 1 plus xy into x dy plus 1 minus yx into y dx is equals to 0. So here multiply this x inside, x dy multiply into the inside terms, then we get 1 into x dy plus xy into x dy, that is x square y dy, plus y dx into 1 is y dx, and y dx into minus yx is minus y square x into dx is equals to 0. So from here, x dy plus y dx write one side, and then x square y dy minus y square x dx. From this both we can take xy common. So xy into x dy minus y dx is equals to 0. So according to the formula, we have to convert these terms. So now dividing with x square y square. When we divide with x square y square, you will have the formula for this. So when we divide, x dy plus y dx divided by x square y square plus xy of x dy minus y dx divided by x square y square, that equals to when we divide by 0 divided by x square y square gives 0. So here x dy plus y dx is d of x by y and divided by x square y square, plus we have the formula for this. This is equals to d of log of y by x, and that equals to 0. So here x square y square means we can write it as xy whole square, and xy 1 xy will be get cancelled. Plus d of log of y by x is equals to 0. Then here the left two terms are d by x by y, x into y, that equals to d of log of y by x is equals to 0. So when we integrate it on both sides, this integration integration of d into 1 by x and integration of d of log of y by x, that equals to 0. So when we integrate it, this integration and the differentiation gets cancelled. So the left over is 1 by x into y plus log of y by x is equals to c.